Good afternoon everyone and welcome to my YouTube channel. So let's continue with our absolute value inequalities. We are just going to solve one problem, which is, let's say if we have solve x minus 2 like that over our x plus our 3 like that. So if we have such a problem, we have a greater than or equal to our 4 like that. So how can we do this one? So it is very simple. So in our previous video, we looked at if the inequality is facing this direction, we are going to be using, or if the inequality is facing this direction, we are going to use and. So this one comes out with two solutions. We are going to say our x minus 2 like that over our x plus our 3 like that. Then we are going to maintain everything. If we maintain everything, we are going to say greater than or equal to positive 4 without changing the sign. Then we are going to say or we are going to have our x minus 2 like that over our x plus 3 should be less than or equal to a negative 4. So immediately the inequality changes, even the sign here should change. So if that's the case, let us solve them independently. So knowing how we deal with rational inequalities, we are going to take our 4 this side. We are going to have our x minus 2 over our x plus 3 should be minus our 4 should be greater than or equal to 0 if we take the 4 this side. From here, we are going to take our lowest common denominator, which is our x minus our x plus 3 like that. Then here we are going to have our x minus 2 like that, minus 4. Now, the way it is, this one multiplies this, so we are going to have open brackets our x plus our 3 like that. We close like that, should be greater than or equal to 0 like that. With that said, we are going to have our x minus 2, negative 4 by x, it will be negative 4x, negative 4 by 3, it will be negative 12, over we have our x plus our 3 like that, greater than or equal to 0. Take note that x cannot be equal to negative 3. Why negative 3? Because the denominator, if I put, let's say on the denominator, I put negative 3 plus 3, which will give me the denominator to be 0. If the denominator is 0, then the equation is undefined. It cannot be solved. So therefore, x should not be equal to negative 3. Let us simplify our problem. So we are going to have our x minus 4x, it will be negative 3x like that. Then we have negative 2 minus 12, it will be negative 14 over our x plus our 3 like that, greater than or equal to 0 like that. So from here, we know how to deal with the inequalities. We are going to find now our critical values. Our critical values are the zeros of the equation. So the critical value can make this one equal to 0, though we are not going to include it in the final solution. You will see how we will work it out. So we are going to have our negative 3x minus 14 should be equal to 0. Another one, we have our x plus our 3 should be equal to 0. So these are our critical values. So we are going to have negative 3x. We take the 14 the other side, it will be equal to positive 14 like that, over negative 3 over negative 3. So our x is equal to our negative 14 over our 3 like that. Then we also have, we take the x this side, it will be x should be equal to negative 3 like that. So when we have found our critical values, we are supposed to come up with a table. So the table is such that we are going to have something like this. Here we are going to have the smallest value. So negative 14 over 3 is smaller than negative 3 because negative 14 over 3 is approximately a negative 4.6. So you can investigate this by dividing 14 divided by 3. That's 4. Remainder is 2. You write a point. You add 0 here. 20 divided by 3. That's 6. So the 6 can continue like that. So the negative 14 over 3 is approximately negative 4.67. So we are going to write our negative 14 over 3 like that. Then here we are also going to write our negative 3. Now if you ask yourself, all the values that are on the left of negative 14 over 3 are less than this value, because as you move to this side, the values keep reducing. Therefore, we are going to say all the x values, let's take all these values that are here to be less. So all these values are less than negative 14 over our 3, because we are moving to this direction. If we look at all the values of x that are this side, we can be able to say all these values are greater. As you can see, as you move to your right, you can have negative 2, negative 1, you could have 0. So all these values that are this side are greater than this critical value. So you compare with your critical value. Therefore, you will say that your x is greater than the negative 3. So all these values are greater than negative 3. Here, we are looking at the interval, which means that we are looking at the numbers that are between. So the numbers that are between negative 14 and negative 3 are such that this value that is here, is greater than negative 14 over 3. As you move to your right, the values increase. Therefore, you will say that negative 14 over your 3 is less than x, like that. But at the same time, the highest value, let's say it's here, it is less than negative 3. So we are looking at values that are in between these two critical values. So you will say less than negative 3. So the highest, it will be this point, which is less than negative 3. So if that's the case, we are going to now find. We are now going to use our table. So using our table, we will first say factors. So our factors are the values that we had here. So we have our negative 3x minus 14 as our first factor, negative 3x minus our 14, like that. The other factor is such that we have our x plus our 3, like that. Then these two numbers are dividing. So therefore, their result is called a quotient. If you look, this divided by this, it gives you what we call a quotient, like that. Then here what you're going to write is the first one, which is this interval. Our x is less than negative 14 over 3. Then here you are going to write a negative 14 over 3 less x less negative 3, like that. Last but not the least, you have your x is greater than your negative 3, like that. So with this done, we are going to come up with the values, the possible values of our x. If you look here, if your x is less than negative 14 over 3, we said that the approximate value of our 14 over 3 was negative 4.67. So you can pick any value that is less than this, such as x is equal to negative 5, like that. If we have an interval, negative 14 over 3 is less than x but less than 3. So the number that could be less than negative 14 over 3 but greater than negative 14 over 3 but less than negative 3 is a negative 4. So a negative 4 will be in between. We can use, if you want, 3.1, 3.2 is okay, 4. Whatever value that you want, it's still okay, as long as it's not greater than this, as long as at the same time, as long as it's not less than this, as long as it's not also greater than negative 3. Then last but not the least, if your x is greater than negative 3, that means that your x could be negative 2 if you want, negative 1 if you want, but for the sake of simplicity, let's use 0. 0 is greater than negative 3. So with that said, we are going to now substitute. So this is the sign table. We're just going to be putting our sign like that. So if x is equal to negative 5, we are going to say our negative, where there is x, we put negative 5. So we are going to have 3 negative 5, like that, minus 14. So we are going to have our negative 3 times negative 5 will give you positive 15 minus 14, which will give you positive 1. So positive 1, since it's positive, it shall be positive there. Then if we put negative 5 here, it will be negative 5 then plus our 3 like that. Negative 5 plus 3 is a negative value, which is negative 2. You just put a negative. Then you divide. Positive divided by negative, it will give you a negative like that. We are here. When you put your negative 4 here, we are going to have something like negative 3, open brackets, negative 4. Then we have our minus our 14 like that. Negative 3 times negative 4 will give you positive 12 minus 14, which will give you negative 2. So we are going to put a negative here. Then from there we have here negative 4. If we put it here, negative 4 plus 3, it will be a negative 1 like that. Negative divided by negative, it shall be a positive like that. We are here. If we get a 0, we put it here. It shall be a negative 3. Where there is x, we put 0 minus 14, which will give us something like a 0 minus 14, which is just negative 14 like that. So we are going to have a negative here. Then we have a, if we put 0 here, it will be 0 plus 3, which is positive 3. So the sign will be positive. Negative divided by positive, it shall be negative. So to pick our solution, we are going to look at how our inequality is. So our inequality is such that we have, so our inequality was saying negative 3x minus 14 over x plus 3 should be greater than 0. So if you see your inequality, it's saying that it should be greater than 0. Meaning to say, for your solution, you will be able to say that this shall be equal to, what value is greater? So whatever you divide here, it should be greater. So if you look at your sign, you have a negative, positive, and a negative. So you're going to pick a positive simply because a positive is the only thing that can be greater than 0. So you will pick a positive. If it was less than or equal to, we are going to pick a negative, since a negative is the one that can be less than 0. So in this case, we are going to pick a positive. So on the positive, there is this interval, which is saying that negative 14. So we have a negative 14 over 3 less than our x less than our negative 3 like that. So this is our solution. However, since it's saying that greater than or equal to, even here the equal to should show. So the equal to will only show for negative 14 over 3. Here we are not going to put equal to, simply because we said that x cannot be equal to negative 3 to avoid that process of undefined. Therefore, here we are just going to have this as our solution. To write this as an interval notation, we are going to write our square bracket, since negative 14 over our 3 should be included. Then we have comma our negative 3 like that. Now negative 3 should not be included, so we are going to do that. So this is our solution for that first part. We are going to do the same for the other part. So remember, our question is saying that, so remember, we have produced the solution to this one. Therefore, we also need to produce the solution for this other part. So we are going to say that we have our x minus 2 over our x plus our 3 should be less than or equal to negative 4. So taking the 4 that side, it will be x minus 2 over our x plus our 3. Then we have plus 4 less than or equal to our negative our 0 there. So it shall be, let's x plus 3 be our common denominator. Then we have our x minus 2. We have plus 4 multiplies this. We are going to have our x plus our 3 like that should be less than or equal to our 0 like that. So we are going to have our x minus our 2 plus our 4 times x, it will be 4x. 4 times 3, it will be positive 12 like that, over our x plus our 3 less than or equal to our 0 like that. Therefore, well, what we are going to do is we are going to have our x minus 2 there plus 4x plus 12 like that. So our 4 plus x will be our 5x there. negative 2 plus 12, it will be plus our 10 there. Then we are going to have our x plus 3 less than or equal to 0. So same approach. From here we are going to find our critical values. So our critical values are our zeros of the equation. So it shall be 5x plus our 10 should be equal to 0. So the critical value equates to 0. Even x plus our 3 should be equal to 0. So we have taken the 10 the other side, we are going to have 5x should be equal to negative 10 over 5 over 5. So our x value should be equal to negative 2 there. Then we are going to have our x should be equal to our negative 3 like that if we take it the other side. So with these critical values, we can come up with a table. So our table will be such that negative 3 is less, so we put it here, negative 2 is here. So all the values that are this side are less than negative 3. So we are going to say x is less than negative 3. All the values that are on the right of this are greater than our negative 2. So we are going to say x is greater than our negative 2. From here, all the values that are in between this should be such that we are going to have our negative 3 is less than x, because or is greater than x. This value that is here is greater than negative 3, but at the same time the last value here is less than negative 2. So we are going to have that. So we can use this to come up with our table. So for this one, our factors are such that we have 5x plus 10. So we are going to put our 5x there. So we have our 5x plus 10 there. Then the other factor is x plus our 3. X plus our 3 like that. So this one, we are going to have the inequalities are such that x is less than negative 3. Then here we have an interval, which is our negative 3 less x less our negative 2. Finally, we also have our x is greater than our negative 2 there. So here we are now going to put our values. If x is less than negative 3, it means to say x could be equal to negative 4 there. If we have an interval between negative 3 and negative 2 there, we could have a decimal point number. So if you look at how it is, our negative 2 is here, our negative 3 is here, our negative 2. So one of the numbers that can be found between there, it's negative 2.5. Even negative 2.1 is okay, even a negative 2.9, but let's pick what we can easily work with. Let's go with 2.5 there. So we are going to put our x to be equal to negative 2.5. Then here, if x is greater than negative 2, it could be any value. For the sake of simplicity, let's use a 0. So we are going to put, when we put our negative 4 there, it shall be a 5. Where there is x, we put negative 4. Then we have plus 10. Our negative 5 times negative 4 will give us negative 20 plus 10, which will give us negative 10. So here we are going to put a negative. If we put negative 4 here, it shall be negative 4 plus 3, which is negative. We put a negative. Negative divided by negative, it shall be positive. We are here, if we put negative 2.5, here we are going to have something like our, for the equation says 5x plus our 10. Then we are going to have our 5. Where there is x, we put 2.5. Then negative 2.5 for that matter, we have plus our 10. Then we are going to multiply our 5. So what we can do is just get, instead of using 2.5, get the negative 25, multiply it by 5. Then you are going to have 5 times 5, it will give you 25. So 5 remainder 2 times 5, it will give you 10, plus 2, it will give you 12, negative for that matter. Now since the point was here, it means to say you move one decimal point to the left. So we are going to have for this one, 5 times negative 2.5, you are going to have negative 12.5, then you have plus 10 there. Negative 12.5 plus 10 will give you negative 2.5. So it is negative here. So you are going to put your negative. Then from there, you are going to have x plus your 3. If you put negative 2.5 here, it will be negative 2.5. then you have plus our 3. Negative 2.5 is less than 3, so it shall be a positive value, which is 0.5, positive 0.5. So you are going to write positive. Negative divided by positive, it shall be a negative there. Last but not the least, we are going to put a 0 there. So where there is x, we put 0 plus 10. So we are going to have positive like that. When we put 5 where there is x, we put 0. It will be 5 times 0 will be 0 plus 10, which will be positive 10. So here it will be positive. Then here our x, we put 0. It will be 0 plus 3, which will be a positive 3. Here we're going to put a positive like that. Positive divided by positive, it shall be positive. Now let's look at our inequality and see the condition. So what we are going to have is we have our 5x plus 10 over this. So when we divide this and this, we should have a value that is less than 0. So the only value that is less than 0 is the negative value. So we are going to take this solution. So our solution will be such that we take this interval, our negative 3 less our x less our negative 2. Now since it's less than or equal to, so where there is this one, we are going to put less than or equal to, but we can't put here because already negative 3 should not be part of our solution. If you remember, if you put negative 3 here, it will be undefined. So we have found our solutions for the two parts. So this one in interval notation, we are going to have our negative 3 like that, comma, we have our negative 2, an open circle, meaning it's not included. Then we use a closed circle there. So we have produced two solutions. So we had this one. The solution for this one was such that we had a negative 14 over 3, comma, negative 3. Then we also have, or we found this one, the solution to be negative 3, comma, our negative 2 like that. Excuse, with 2 included. So to find our final solution, we are going to say negative 14 over our 3, comma, negative 3 there. Where there is or, we use union. Then we are going to have negative 3, comma, negative 2 like that. So this is our solution. So just in case the question was like this, so this was our question. But let's say just in case the inequality was facing this other direction, so we could have split them in such a way that we are going to say x minus 2 over our x plus 3. Then we are going to say less than or equal to 4 like that. Instead of using or, we are going to use and. We are going to have our x minus 2 over our x plus our 3. Then change the inequality. It will now face this direction to say negative of our 4 if you change the sign. So each procedure will be the same. The result will be such that it will produce the same answers. So we are going to have negative 14 over 3, negative 14 over 3 like that. Then we have comma, our negative 3 there. Now the only difference is that here we are going to use and like that. Even here the solutions will be the same, but as long as the inequality is facing the less than or equal to or the less than, just you use and here. Then therefore it shall be, even here it will produce you the same answers which we found, negative 3, comma, our negative 2 like that. So since we are using and here, that means to say we are going to intersect negative 14 over 3, comma, our negative 3 like that. Then we are going to have and, meaning to say intersection of negative 3, comma, our negative 2 like that. So this could be our solution for that. But as you can see, 3 is not included here, and here it's not included. Therefore the intersection between these two sets would come out to say that if we are to write the set, it would be such that it would be an empty set, because negative 3 is not included. That's why we have an open circle. Even here it's not included, but that's the only thing that they share in common. Now since there is nothing that is found in both sets, it would mean to say the solution set would be an empty set. So that is how we go about that. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.